Now I'll demonstrate the harmonic support function of the inverter. We have the inverter grid tied with a house load drawing 1.6 kilowatts, all coming from the inverter with no current coming in from the grid. The inverter is set up with maximum output resistance, so it is current sourcing, but we can reduce that resistance so it becomes more and more a voltage source, a low impedance voltage source running in parallel with the grid. And when it is low impedance, it tries to force the grid voltage to be a true sinusoid, and in doing that it injects harmonics, predominantly fifth harmonic, back into the grid. And this is the harmonic that the electronic loads, which are causing the flat top, are pulling out of the grid. So we can reduce the harmonics that the grid has to supply. And although this isn't required by any regulations at the moment, it is a function that the grid operators would be interested in, and it would reduce the harmonic load that they have to supply from their distribution transformers. So now I'll reduce the impedance of the inverter and you'll see the harmonics injected into the grid slowly increase. Okay, this is with the inverter now set to 5 ohms impedance. You can see the harmonics now starting to increase, and the fact that they're going negative while the grid voltage is positive means that we're injecting power into the grid to try and effectively make the flat top a nice round sinusoid. That's now 2 ohms output impedance. One ohm. That's 0 ohm output impedance. Now we just have a bit of intrinsic resistance left in the inverter, and we can actually cancel that out by setting it to a negative virtual resistance. So I'll go down to minus 0.5 of an ohm, which is about as far as we can go. So now with the inverter set to absolute minimum resistance, we're injecting 5 amp peaks at the fifth harmonic into the grid, trying to cancel out the harmonics in the wave shape. You can see that the current is now bouncing around quite a bit, and this is the response of the inverter to very minor changes in grid voltage. So the grid voltage is just changing up and down, maybe a volt or less, and the inverter is reacting to that. Okay, going back up in resistance, 0 ohms. One ohm. 2 ohms, 5 ohms, and up to maximum resistance. So we are now current sourcing again.